Hello, this is section 4.8, radical equations and power functions. So property of the rational exponents. So when m and be a positive integer, and then m or n is the lowest term and n is greater or equal to 2. And also r and p are the rational number. Assume that b is a non-zero real number and that each expression is a real number. So first one, b to the m over n, which is same as b to the nth power to the 1 over nth power. Or you can just interchange that. And then which is when you have a 4 to the third, same as 3 to the 1 half. And then you change the 4 as 1 half and third power equal to 8. And then m over b to the m over nth power, same as the nth root of b to the nth power, or you can pull the nth power outside, which is when you have a 2/3 means the cube root of x squared, and then you got that, and then you can get this. And number 3 is a power rule, so r and p, you can multiply that as a power, and then you can multiply 3 over 2 power as a fourth power, makes that as a simplify as a 64 later. And then when you have a negative power, we can always change the positive. And then when you have a multiply two number with the same base and then exponent, you can just add them up. We call the product rule. And then same, so 3 times 3, but each 3 has a different power, but same power doesn't matter, so you need to add them up and then simplify. This is what we call the quotient rule. So when you have a division with the same base, and then you just need to subtract the exponents, and then yeah, that's what you're gonna get. Okay, so we needed it, we're gonna use it. All right, so example 1, so simplify. So in order to simplify it, so which means this is actually the same as 8 to the 2/3. But as an 8, I'm going to change the 8 as a 2 cube because I want to match this 3 with this 3. And then I can use the product rule, which is I can multiply 3 to the 2/3. And then the 3 cancels out, it becomes 2 squared, becomes a 4. Okay, for the second one, this is multiply the same number 9, which means you can just combine the exponent together. You can just add them up with the negative 5 over 6, which is when you order the adding them, you need to actually find the LCD. So LCD is a 6. So 3, you got to multiply by 2 both sides, which is a negative 2. Why is it negative? Oh, okay. Sorry about that. Why is it negative? It's a positive, okay? So multiply 2 both sides, it becomes a 6. And then minus 5, which is 9 to the 1 over. Oh, it's a 3. What am I doing? Sorry. My mess up. Sorry. So it's going to be 3, which is a negative 2 over 6. Oh, so 2. What am I doing? Yeah, I messed up. Sorry. It's going to be 2, and then it's going to be erase that. Sorry about that. It's going to be negative 3 over 6, which becomes negative 1 half. And then you can always change the negative power to positive, flipping the number. And then 9 is actually about 3 squared and a half, and 2 times a half is a 1. So this compound is a 1/3. Alright, same thing too, but this one I see the negative exponent, so I'm going to change as a positive, but you cannot change the base, okay? Only the base changing. Now 1 over, and then 64 is the same as negative 4 cubed, because there's a third power here, and then when you multiply 3 times 2/3, becomes 3 cancels out, you got 1 over negative 4 squared. It becomes 1 over 16. For the D, same base, dividing, so you can just subtract the exponents with a 1/6. Find the LCD, which is a 6. 3 times 2, 2 times 4 minus 1, and 16 is going to be 3 over 6, which is the same as 1 half, which is 4 squared, is a 16. And then 2 times 1 half is a 4. And then this we call the power rule. So 25, 1/3 times 2 over 3. Oh, sorry. What am I doing? Multiply by 3 over 2, which is 3 cancels out. So 25 is 1 half. And then 25 is 5 squared, because you need to match the as a 2. So 2 times 1 half is 1. So it becomes, this is a 5. All right, example 2. All right, now use the positive exponent to write down each expressions, okay? So when you simplify this, 4 come as a 2, but x stays in the root, and then 2, and the x is a power as there's a root is 2, and the power is 1, so 1/2. So you can write this. And for this one, z, and always 4/3. Always the roots come in denominator, okay? And this one is going to get y, and then it's going to be -2/5, okay? Which is, if you want to change the positive, 1/y to the 2/5 power. Okay, this one is a cube root of, right? So inside is y to the 1/2 times another y to the 1/3. So if you change that cube root of, you got y, and then we can add the 1/2 to the 1/3, which is the cube root of y to the 6th power, so 3 plus 2, and then you got cube root of y to the 5/6. And that's the same as y is 5/6/3, which is same as 5/6 times 1/3, which is same as y 5/18th power. So this is what it is. All right, now example functions involving radical. So expression involving the radical are sometimes used to define the radical function. So two common radical functions are the square root function and the cube root function. So evaluate each function for the given value of x. So x is 81, so I'm putting in 81 in the function. Cube root of 80, fourth root of 81, which is 81 is 2 to the 4. And then it come out at 2 4/4 as a 1, so it is a 2. Oh, so what am I talking about? Sorry about that. It's a 3 to 4. What am I talking about? Sorry. I'm not good condition today. Okay, so 3 to the 4, and then it's gonna be 3. All right, next problem. I have x is a 16, so g of 16, and then fourth root of 4 times 16, which is 4 times 16 is a 64, and then what I keep messing it up. Sorry about that. Cube and cube, right? Sorry about that. And then 64 is 4 cube. And then this is 4, 3/3, which is a 1, becomes a 4. Now, h of 4, you got square root of 4 to the 5th. So 4 to the 5th, same as 4 to the 5/2. And then 4 is a 2 square to the 5/2 power. And then when you multiply 2 times 5/2, 2 cancel, become 2/5, and becomes 32. All right, we're going to graph this one. Okay, so in this time, okay, it's a cube root, so you can use any x's you can. But for me, I like to use 1, 0, and then 2 and 9. The other side, 0 and -7. Okay, and then I'm going to start plugging in. So if I plug it in 1, and then 0, come out as 0. If you plug it in 2, -1, come out as -1. If you plug it in 9, -8, come out as -2. If you plug it in 0, plus 1 is 1. -7, which is an 8, so it becomes a 2. So you can just then plug it in. So -7 and 2, so 5 and 6, maybe about here. So as a 2 up here. And then the 0, 1, 1, 0, and then 2, -1, and then 9 is on. So yeah, so this is gonna be graph gonna be this, adding to that, and then all the way to right here. Okay, example 5. Number of the number n is different plants species that live on the Galapagos Island is sometimes related to the island's area A in square miles by the function. So n of A equal to 28.6 cube root of A. Approximate n to the nearest whole number for the island of 500 square miles and 100 square miles. And then so n of area A is 500. Which is 28.6 cube root of 500. And then you got to use a calculator. Use a cube root. It's about 227. And then n of 1000, which is 28.6 times cube root of 1000. So use a calculator. You say 286. So now So n is the number of the different planes of the species on the island. Okay, so you put there are 5 different planes and then 1,000 different planes. But does the n doubles if a doubles? Oh, the n is actually, sorry about the n is the number of the different species, but the a is the area, sorry. So when you have an area was the case, okay. All right, so you got is that double? So yeah, so the area was 500 to the 1,000, which was the double. But compared to the number of the n, which is the species, okay, 286, but it's not double. Okay, so yeah, every area is double doesn't mean that it's the number of the species is going to be double. Okay. All right, next page. Now, equation involving the radical. So we are trying to solving the radical equation. But when you have a radical equation, we have to make sure to check the solution. Could be the solution, okay? Because you might get the extraneous solutions. So in this time, in order to do the radical equation, first of all, you shouldn't have any radical in the equation. So you need to isolate the radical. But this problem is already been isolated. Now you can just square both sides. And then you got 4x squared equals to 21. And then 5x comes out. And then since becomes a quadratic equation, so make the quadratic standard form. So I got 4x squared plus 5x minus 21, which is a factor as 4x minus 7 times x plus 3. And then you got the two solution as x equal to 7 over 4. And the other one is negative 3. So we need to check. So x equal to 7 over 4, make sure it works on the equation. So 2 times of 7 over 4 isn't the same as square root of 21 times 5 times 7 over 4. So this is a 7 over 2. And the other side is a 21 times, minus 35 over 4. So other side, 21 is same as 84, subtract 35 over 4, which is 49 over 4, which will come out as 7 over 2, right? So, yep, it works. So, 7 over 4 is fine. So, this is a solution. And then plug in negative 3. So, 2 times negative 3 equal to square root of 21 minus 5 times negative 3. But it's a negative 6, but this becomes 21 plus 15, which is 36, which is going to be a 6. So negative 6 not equal to 6 is no. So we can use a 3. So we only got one solution for this case. Okay. But when you have a cube root, you don't need to actually check it out, because when you have a cube root radical, when you have a cube root, you're never going to get the extraneous. Okay. So this time just subtract 4 to isolate the radical. We go to negative 2. It's fine. Now we need to cancel the cube root, which means we need to power 3, which is 3x minus 1 come out, become negative 8, and plus 1 both sides. 3x equal to negative 7 divided by 3 is a negative 7/3. All right, what if you have a 2 radical? Yeah, I want to isolate the one radical at a time. So I want to actually isolate the radical, which is more complicated. So I want to leave 13 minus 2x radical, 5 minus 2 radical 2x. And then I score them. So when I score them, I got 13 minus 2x. But this is same as 5 minus radical 2x times 5 minus radical 2x. And then when you are multiplying it, 13 minus 2x, it becomes 25 minus 10 radical 2x and plus 2x. Now we need to isolate these radicals again, okay? So in order to do this, you need to subtract 25. You need to subtract 2x. And then I get negative 4x. I just move up here, okay? So negative 4x minus 12, which equal to negative 10 radical 2x. Oh, I want to make a simplified equation. So I want to divide by actually negative 2 both sides. And then I get 2x plus 6 equal to 5 times square root of 2x. And then I square both sides. And then I got 4x squared plus 24x plus 36 equal to the 5 stays of 5, but the 2x squared, 5 stays of 25, and then 2x comes out. So you got 4x squared plus 24x plus 36 equal to 50x. And then subtract 50x both sides. You got 4x squared minus 26x, and then plus 36 equal to 0, and divide by 2. And then you got 2x squared minus 13x plus 18 equal to 0. It's a factor of both, so 2x minus 9, x minus 2. So 1x is a 9 over 2 and 2. But this won't work for the equation. All right, so now we have a power function and the model. So power function means that we have a power here. So power as a 2, 3/4, and 0.4, and this is actually x to the 2/3 power, right? Okay. And then also the power function form of the root, yeah, which is this going to be the x to the 1 over n. And then as a power, so the power 1, of course, is a straight line because linear. And then power is greater than 1. And then function goes this way. And then power is less than 1 is kind of this way. So a little bit different, right? Okay, let's look at the number 9. So in the number 9, wingspan L in feet, upper weight W pound is given by L equal to 2.43 W to the power of 0.0026. Estimate the wingspan of the bird and the weight of 5.2 pounds. So in order to find the wingspan L, which is 2.43, and then W is actually the 5.2, that's a weight, and to the power of 0.3326, and then I got about 4.2, that's the wingspan. Now we are solving for x from this equation, so first of all, we need to isolate the 3x to the 3 over 2 power, which is 81, and divide by 3 because we're not using that. So x to the 3 over 2 equal to 27. And then in order to get an x to the first power, I need to raise the power of 2/3 both sides, which becomes 1. And then 27 is the same as 3 cubed of the 2/3, and that becomes 3 times 2/3, which is x equal to 3 cancel, is a 3 square, x equal to the 9. And then so for 11, which is this problem, okay, you can use the substitutions. Okay, so let's say let u is n to the -1, which means n to the -1 becomes the u squared. So I can write this as a nu squared plus 14u, and then subtract 15 both sides, the minus 15 equal to 0. It's a factorable, so for u minus 3 times and 2u plus 5 equal to 0, and the u becomes 3 over 4, and u equal to -5 over 2. But u was actually the n to the -1, and n to the -1 power was -5 over 2. And 1 over n is a 5 over 2. And then when you cross multiply, 3n equal to 4, so n equal to 4/3. That's one solution. And then if you cross multiply, 5n is a negative. So 5n equal to -2, so n equal to -2 over 5. So that's another solution for this equation. Same thing here too. I want to just let the u is x to the 1/3, which makes 3 times u squared minus u minus 2. So factor it out. It's going to be 3u plus 2 times u minus 1. The u is -2/3, and the u is a 1, but u is originally is x to the 1/3 power. X to the 1/3 power was u. And then in order to get an x to the 1 power, you need to raise the power 2. And then you get the -8 over 27. Power 3, raise them, and you got an x equal to 1. So these are the two solutions for this equation. All right, that's for the 4.8. Thank you for listening.